So Nancy's talking about these two perspectives, the perspective of the producer of scientific knowledge and the perspective of the user of scientific knowledge. I want to talk about these as the scientist and the engineer. Now in the social setting, the engineer is a social engineer. As with the bike helmet, implementing bike helmet laws is essentially social engineering. You're trying to change the organizational structure of the society, so forth. But we also see the person who, or the people who put together the bike helmet itself and did the tests on it to make sure that it's going to take the impact and be safe and so forth. Those are engineers too. They're creating something that is going to, at least in their mind, probably solve a problem. So in general, science is concerned with the way things are, okay? How the world works, how the world is. The policy perspective, the social engineer, on the other hand, is concerned with how to change the world, how to change the way things are, how to change the way things work. These are the different perspectives. Policy is about problem solving. It's about making the world better. It's about changing how things are to move from a current situation to what is conceivably a better situation. Now, the overall scientific worldview has tended to see the world as an integrated network of objective, fixed, causal relations. This has been characterized generally as the clockwork universe image of reality. In such a model, everything is synchronized, everything is locked together in deterministic relations. All knowledge in this scientific model is scientific knowledge, knowledge of how the world is and how it works. But if this is correct, then policy, social engineering, is the designing and implementing of a policy is simply applied science. And the suggestion here is that if you had more and more scientific knowledge, then you could sort of logically reason how to change the world. Of course, if the world is all deterministic, it's not clear that you have the ability to change the world in any deliberate manner, but we'll leave that out for the moment. Now, this scientific model, it's interesting, but engineers disagree with this. So let me give you the engineering perspective, which is nicely expressed by Walter Vincenti in his book, What Engineers Know and How They Know It. So Vincenti says this, he says, engineering knowledge, though pursued at great effort and expense in schools of engineering, receives little attention from scholars in other disciplines. Most such people, when they pay heed to engineering at all, tend to think of it as applied science. Modern engineers are seen as taking their knowledge from scientists and by some occasionally dramatic, but probably intellectually uninteresting process, using this knowledge to fashion material artifacts. I love that phrase. Let me read that again. Modern engineers are seen as taking their knowledge from scientists and by some occasionally dramatic but probably intellectually uninteresting process, using this knowledge to fashion material artifacts. He goes on. From this point of view, studying the epistemology, that's the theory of knowledge of science, should automatically subsume the knowledge content of engineering. And here's a kicker. Engineers know from experience that this is untrue. From the engineering perspective, technology appears not as derivative from science, but as an autonomous, as a separate body of knowledge. This view of technology, he goes on, and hence of engineering, as other than science, accords with statements sometimes made by engineers, such as the following by a British engineer to the Royal Aeronautical Society in 1922. Aeroplanes are not designed by science, but by art, in spite of some pretense and humbug to the contrary. I do not mean to suggest for one moment that engineering can do without science. On the contrary, it stands on scientific foundations. But there's a big gap between scientific research and engineering product, which has to be bridged by the art of the engineer. From the engineering point of view, then, knowledge is real and meaningful if and only if it's useful. Supposedly deterministic knowledge, telling us what must happen no matter what, is useless. What science reveals is what might be called islands of knowledge that can be thought of individually as mechanical. But the overall system is not mechanical. It's flexible. It is clock-like, but it's also cloud-like, flexible, where the islands or particles can move independently of each other. They're not locked in this clockwork sense. There's cloud-likeness and there's clock-likeness in the universe. Now, as it turns out, this is one of the deep issues in science of this in the 20th century. This is exactly what quantum theory discovered, which is that there is this clock-like aspect of the universe and this cloud-like aspect of the universe, and they don't have any clear common denominator. There's no way to really put them together. We'll talk about that next video.